Assignment, Chapter 6, is to estimate a firm's beta using Excel, and then to answer a few questions about your estimate. This video is to help you complete the assignment. To begin, you should have something called Data Analysis in your toolbar. So click on the Data tab, and you'll see that over on the upper right, I don't see anything that says Data Analysis. I actually need to load that. So I'm going to go here to File, choose Options, select Add-ins, and in the bottom we see Excel Add-ins. Hit Go. And I need to load these first two items here, Analysis Toolpack and the Analysis Toolpack VBA. Once I load those two items, I hit OK. And when I'm in my data view, over here in the upper right, you can see there's my data analysis. Great. So the assignment instructions asked you to gather monthly data, of closing data for stock prices. And I've done this for one firm, J&J, so Johnson & Johnson. Right here, you can see I've got my adjusted closing prices, and I've intentionally chosen a data range that you would not be using for your assignment. And then I've come over here to the S&P 500, and I've done the same thing. So you have instructions, pretty clear instructions in your assignment, how to get that information. The next thing we need to do, of course, is we need to calculate returns from the actual price data. I don't want to know what the prices are as much as I want to know what the returns are. So I'm going to hit my Control-tilde key and show you what the equations are to calculate the returns for Johnson & Johnson. Let me go back. And what I'm going to do is I'm going to take the price at the end of the period. So I'm starting in March of 2010, going to April of 2010. The end of the period is the April price of $50.30, and the beginning price is the March price of $51. So the return here looks negative. Price went down, and you can see that you have a negative return here for Johnson & Johnson right there, negative 0.138. So in order to calculate this value, let me highlight this here. I'm just going to again hit my Control-tilde key. And I'm taking the price at the end of the period, B15, minus the price at the beginning of the period, B14. So those are those 2 months data. And then I divide by the price we started with. And I simply repeat that process for both my company, Johnson & Johnson, and the market, the S&P 500 in this case. Now, I'm going to run a regression, and to run a regression analysis, we're going to do a simple linear regression. And to do that, you need both a dependent variable, in our case, the company, Johnson & Johnson, and an independent variable. And for the independent variable today, we're going to use the Standard & Poor's 500 index as our market portfolio. Because we're running a simple linear regression, it would be good to know that the relationship among the returns is in fact linear. So I'm going to run a scatter plot. So I come up here and I insert, and I'm going to come over here. I'm going to do just a scatter plot like this, and I'm going to highlight my Johnson & Johnson returns, and I'm going to highlight the S&P 500 returns. And when I do that, I get something that looks like this. I get a scatter plot. And if you look at this information, pull that over a little bit for us. If you look at that, it looks to be a pattern there. It looks like as the returns in the S&P 500 go up, the returns on Johnson & Johnson goes up. So if I imagine this, I can see a bit of a linear relationship running from the lower left to the upper right. That looks reasonably linear to me. I'm going to be happy to run a linear regression. So this cruise back over to our results. Now, how do you run a linear regression? Well, it's quite easy in Excel as long as we have that data analysis information. So I'm going to click on the Data tab, come over here to the Data Analysis and click on that. And we get a little drop-down menu, and on that drop-down menu, one of the choices will be a regression. Right here. So I'm going to highlight that regression. And it's going to ask for a Y range. That's my dependent variable. So I simply highlight all of the information. And if you highlight the name of the company, then you'll be able to put labels. So my Johnson & Johnson return data will go in this column. My S&P 500 return data will go in the next column, the X range. Maybe you had labels, maybe you didn't. And you can either output it to a particular spot in your spreadsheet or just let it go to a different tab. Ask for standardized residuals and ask for a residual plot. Those are the only two items you'll click down there. Hit OK, and miraculously everything pops up for us. Now here's what your output looks like. We start with some regression statistics right here at the top. And I like to pay attention to two items. I've highlighted these two items here for you in yellow. We have the multiple R. That's just a fancy way of saying the correlation coefficient. Now you'll notice this number of 0.53 is a positive number. It's really the absolute value of your correlation coefficient. It will always be positive whether the relationship is positive or negative. We have a positive relationship because it appeared as though, as we went from the lower left to the upper right, as the returns in the market increased, the returns on our company increased. So the R square has another name. It goes by the name of coefficient of determination. And that value, that 0.283, that tells us what percentage of the variability in returns for, in our case, Johnson & Johnson, is explained by variability of returns in the marketplace, in this case, the S&P 500. It's really pretty nice. Just by looking at returns in the market, we can identify a little over 25% of what is going to happen to our company. That's a very good relationship in using market information. I'm going to move down from here to the ANOVA output. ANOVA stands for analysis of variance. Just slide over here a little bit. Take a look at the item I highlighted here. I highlighted two items, the F value right there, and the significance of F. And the significance of F is what's known as a p-value, and we like to get very, very, very small p-values, and we've accomplished that here. That value of 1.2 e to the negative 0.5, that means there are 4 zeros in front of that 1. So the significance is 0.000012. A little bit of shorthand there. So if that number is smaller than 0.05, we have a significant relationship between those two variables we just put in there, return in the market and return in our company. Now let's go down a little bit more and we get to the regression output. And I've highlighted a couple of items here as well. Before I ran this regression, I looked up an estimate for Johnson & Johnson on finance.yahoo.com, and it was a 0.53. Now, as you know from estimating betas, you'll know that the market has an average beta of 1.0, and anything less than that would indicate a firm of less than average risk. Anything more than that would indicate a firm of more than average risk. So it looks like Johnson & Johnson, with a market estimated beta of 0.53, has a small amount of risk relative to the market. We have estimated that relationship to be 0.578, right there. So about 0.58. That's a very close estimate. You may not be that close when you run the estimate for your company. There are many reasons why that estimate may be close or why it might be far away. Some reasons why it might be far away could include the beta estimate that is being provided by finance.yahoo. There may be some proprietary information and some changes that they have made in estimating that beta. There may be a different time period involved. They may be anticipating the relationship in the future as opposed to a historical relationship, such as we have just estimated. So betas tend to change, firms tend to change, the market tends to change, and those relationships tend to change. So don't be surprised if your beta is not as close as what we've been able to estimate here. You didn't really think I was going to give you an example where I was a long ways off. I have to make it look like this works all the time, you know. Let's continue over here. You'll notice that the p-value, again, for our S&P 500 variable, that's our independent variable, the S&P, you'll notice that the p-value is the same as it was up above for the significance of f. Again, that's a very, very low relation or number, indicating there is a strong relationship between those two variables. So it looks like we have a pretty good regression. It looked to be linear to begin with. The regression is significant based on that p-value. The amount of variability explained, we said earlier, was that coefficient of determination, about 28%. And we're going to come down just a little bit more. I asked you to calculate some standardized residuals. And we're going to look at those first, and then we're going to look at a residual plot. The reason I had you calculate the standardized residuals, I'm trying to determine, we have roughly 60 data points, and I'm trying to determine, are any of those, is there not a very good relationship between any of the particular variables? In other words, the return in the market in one time period and the return on, in our case, Johnson & Johnson in the same time period. You might recall from your statistics days that if you instituted something called the empirical rule, that about 95% of observations would be within 2 standard errors of the mean. Well, these standardized residuals are, in a sense, standardized errors. So this observation number 13 on the top, right here, we didn't do a very good job of predicting returns. We were 2.5 standard errors away. So that means there's that particular variable is having undue influence on the relationship. So perhaps when finance.yahoo ran their beta estimate, maybe they tossed this particular relationship out. Or maybe they weren't even using this relationship. If we go down a little bit, it can be off in the other direction as well. And none of these observations are going to show up as being more than 2 standard errors away. Negative 1.8 is the farthest below it gets. So we've got 60 observations. Only one looks a little unusual. That's nice to see. Come down here and take a look at our residual plot. And when you look at a residual plot, you're hoping to find just sort of random dots on that plot. And that's exactly what we find, I think. There's no real pattern in terms of those residual plots. So I'm thinking we have a pretty good regression here. Now, hopefully, in running through this regression, I've answered several of the questions that I asked you to answer when you run your regression. So good luck with that.